All right, when last we met, we talked about ionic compounds and covalent compounds, and we summarized ionic compounds in this way. We said that ionic compounds always contain positive and negative ions. Positive ions are always metals. Negative ions are always nonmetals or groups of nonmetals. In a chemical formula, the sum of the charges of the cations must equal the sum of the charges of the anions. So if you put sodium together with oxygen, oxygen has a -2 charge. You would need 2 sodiums in order for those charges to add up to be 0. So we would write it Na2O. I call this the law of zero charge. The formula of an ionic compound reflects the smallest whole number ratio of ions. So that's basically, they don't form molecules, they form crystal lattices, and it's the lowest ratio. This would be 2 parts sodium to 1 part oxygen. This would be 1 part magnesium to 1 part oxygen. All right. The charges of the representative elements can be predicted from their group numbers. That's our happy atom chart. Representative elements form only one type of charge. That's the happy atom chart. Transition metals tend to form multiple types of charges. We're going to see that today. And the charges it's difficult to predict. Okay? So we are going to take ionic compounds and break them into 2 categories. Type 1 and type 2. Type 1 metals are going to be metals from the representative families, which means 1A, 2A, and 3A. Type 2 are going to be transition metals plus lead and tin and antimony and a few others. All right. Type 1 compounds contain a metal whose charge is invariant from one compound to another when bonded. In other words, it has the same charge. It's monovalent. It only has one valence charge. Okay? And if you think about our happy atom chart, this is very similar. This whole family is a +1 charge, +2 charge, and aluminum is a +3. All right? These are the metals that have only one valence. They're monovalent. All right? Common monoatomic anions. These are our anions. These guys are all up here in this part of the periodic table. They're nonmetals, and you put an "ide" on the end. They all end in "ide." So when you're going to name something, you're going to take the name of the cation, and you're going to, that's the name you put in. It doesn't get any kind of special suffix. And then you take the name of your anion and you add "ide" on the end. KCl is potassium, followed by the base name of the anion, chlor, with the ending "ide." CaO is calcium oxide. All right. Type 2 ionic compounds have a metal that's multivalent. I don't know if we have a picture in here of those. We do not. So hold on just a moment. All right, so I found this document. If you look here, all the ones in yellow are type 1 ions. They all have one charge. All the ones in blue are type 2. All right, so if it's one of these guys in type 2, those are going to be named differently than a type 1. The green ones are all anions. They all end in "ide. All right? For instance, iron forms a 2+ cation in some compounds and a 3+ in others. And if we look at my chart again, we can see iron somewhat blurrily up here, +2, +3. All right, so iron has a +2 and a +3 charge. So if you have an element that contains the iron +2 cation, you would write it as this way. Iron, and you put the +2 in parentheses. This guy would be called iron 2 sulfide. This guy would be iron 3 sulfide. Here, copper has a +1, so this is copper 1 and copper 2 oxide. All right. So you take the name of the cation, in parentheses you use Roman numbers. I realize they don't probably teach you that anymore. This is a 1. This is a 2. That is a 3. That is a 4. That is a 5. That is a 6. Okay? So go ahead and copy that into your notes there. All right, and this shows you how to write it. All right. So here is another table with some different metals. Just for fun, I will point out to you that on the right-hand side over here, iron 2 is called ferrous. Iron 3 is called ferric. When I was in high school, we didn't have this iron 2 in parentheses and iron 3 in parentheses. I had to learn Fe2 was ferrous and Fe3 was ferric. All right, so you're getting off easy. That was only 37 years ago. Yeah, 37 years ago. All right, so there's a picture that's not, I didn't put that into your notes, but you have it on your periodic table. I've just realized looking at your periodic table, it's not the best, so I probably am going to make another handout with something like this. All right. Now, what do you do to figure out the charge? All right, for instance, this guy here, chromium, could be a +2 or a +3, so we got to figure out what he is. Now remember the law of zero charge that I mentioned. All the ions have to add up to 0. Bromine is one of our halogens, so we know bromine has a -1 charge. And we can look at it written this way. It tells us there are 3 of them, so I'm going to multiply him by 3. Now I'm going to put chromium here, and I'm going to solve a math problem. What charge plus a -3, because -1 times 3, equals 0? So x minus 3 equals 0. What does x have to be? It's a +3. So that tells us that this is chromium 3 bromide. All right. So I have a naming practice in there. We've gone flying past 2 of them. So let me pull those up. Chapter 3 notes. All right. So if we look at these first ones, all of these, we have sodium, we have magnesium, we have aluminum, lithium, calcium, and strontium. If we look at our periodic table, or if we look at that set of notes that I opened for you with the different colors, we had lithium, we had magnesium, we had aluminum, we had sodium. All of these are in the yellow. So these are all type 1 naming systems. So let's name this first guy. We have a sodium, we have a chlorine. We're going to put an "ide" on the end of the chlorine. So we're going to name him sodium chloride. I have no idea why that changed colors like that. The next one, we have magnesium. And we have sulfur. So it becomes sulfide. Aluminum, oxide. Now we're going to write the formula. Lithium is a +1. Iodine is a -1. Do those add up to 0? Yes, they do. So we just write Lii. Calcium is a +2. Fluorine is a -1. What do I need to do to get those added up to 0? I need 2 fluorines, right? 2 minus 2 is 0. So I would write him calcium fluoride with a 2. Strontium has a +3. No, I lied. Strontium is a +2 because he's a happy atom in the second family. And we're going to bond him with nitrogen, which is a -3. Now, there's this easy way to do this one. We call it the crisscross method. So if I take this guy and I bring my 2 down there and I bring my 3 down there, now I have 3 times +2, which adds up to +6. 2 times -3, which adds up to -6. Our charges add up to 0, and we have Sr3N2. All right, let's do the other type, the type 2 now. The first thing we're going to have to do, oops. No, we were on this page, weren't we? The first thing we're going to do is figure out what possible charges they could have. Copper could have a +1 or +2. So let's look at who he's bonding with. He's bonding with chlorine. Chlorine's going to have a -1 because he's a halogen. And we're going to multiply him by 2. So what does copper have to be for that to add up to 0? What -2 gives you 0? If you said +2, you are correct. So we call him copper 2 chloride. The next one is copper once again with a bromine. Bromine is also a halogen. He has a -1 charge. There's only one bromine, so copper this time must have a +1 charge. So he's copper 1 bromide. Fe2O3. We know that oxygen is always a -2. So my total charge, I'm going to write it down here, for oxygen is -2 times 3. And we know that iron could be a +2. It could be a +3, so I'm going to call that guy X. And we're going to multiply him by 2. So now I get 2x minus 6 equals 0. What does x have to be? Well, if you said 3, 2 times 3 would be a +6. This is indeed iron 3 oxide. V2O5. Well, vanadium has several different oxidation numbers. So we're going to call this one 2X for vanadium. Oxygen's always a -2, and we have 5 of them. So I'm going to add that in. 2X minus 10 equals 0. What is the charge on vanadium? Vanadium is a plus 5. So we name him vanadium 5 oxide. Copper or chromium and chlorine. Chlorine's a -1. I have 3 of them, so chromium must be a plus 3. So we say chromium 3 chloride. Now the other side gives us the charges. Cobalt, it's telling us that cobalt is going to be a plus 2. And oxygen, you can look up on the chart, is a -2. 2 minus 2 is 0. So this guy is cobalt oxide. You don't put Roman numerals in the formula, only the names. Here it's called lead 4. So that means the lead is going to be a plus 4. Fluorine is a -1. So how am I going to write that? So that adds up to 0. PbF4. Iron 2 nitride, I'm going to do down here so we have more space. Iron 2 means iron's a plus 2. Nitrogen is one of your nonmetals. He's always a -3. So what can I do to get those to add up to 0? Well, once again, we can do the crisscross method. So now we have 3 times 2 plus -3 times 2 equals 0. 6 minus 6 equals 0. So he is Fe3N2. Chromium 3 oxide. Chromium is a plus 3. Oxygen's a -2. Again, we can do the crisscross method. Cr2O3. And finally, copper 2 oxide. Copper is a plus 2. Oxygen's a -2. So we just write it like that. All right, that is all for this portion of naming ionic compounds.